Hi, my name is Talia, and I'm a high school senior who's super passionate about teaching others chemistry and math. This YouTube channel is a supplemental resource to anyone who may be having difficulty in their chemistry classes. This week, I'm going to be talking about bonding and polarity, so if you need help with those topics, feel free to keep on watching. And without further ado, let's get started.
Okay, so in the last video, I talked about Lewis structures, which basically shows how when two or more atoms come together to make a compound, they form bonds and they share electrons. Two electrons are shared in one bond. In this video, I'm going to be taking that to a more advanced level where we talk about different kinds of bonds. There are covalent and ionic bonds, and bonds can also be classified as polar or non-polar. Before we begin, ionic bonds will always be polar, and covalent bonds can be polar or non-polar. So that will set up the explanation for the rest of this video. You can classify the bond type and polarity between two atoms based on the difference in electronegativity values. And these can be calculated using this chart I have here, or there will usually be a chart on your formula sheet for honors chem. So I talked about electronegativity in a previous video, so I'm not going to go too in depth into that, but you use electronegativity to calculate the bond type and bond polarity. So now let's go in depth into each bond type and polarity. So if your difference in electronegativity value between the two atoms is 0 to 1.7, the bond between the two atoms is covalent. And this means that atoms have a similar pull on electrons, so the electrons are not transferred, they are shared between the two atoms. And when the electronegativity change is 1.8 or greater, this means the bond type is ionic. And this means that the electron from the less electronegative atom will be transferred to the more electronegative atom. Then the more electronegative atom will have a slightly negative charge, and the less electronegative atom will have a a positive charge, as I wrote here. So these two are bond types, and this basically classifies whether electrons are shared or if they're transferred. So now we're going to talk about bond polarity, and this is different from bond type because it classifies if the electrons are shared equally or if they're shared unequally. So if the change in electronegativity is between 0 and 0.4, the bond is nonpolar, which this means that the electrons are shared equally between the atoms in the bond. Because the electronegativity values are very similar, the pull on electrons will be the same or very similar from both of the atoms. Therefore, the bond will be nonpolar. When electronegativity is 0.5 or greater, the bond is polar, and this means two different things for covalent and ionic bonds. So for a covalent bond, which we know that means electrons are shared, this means that the electrons are unequally shared. So the more electronegative atom will therefore have a partially negative charge, and the less electronegative element will have a partially positive charge because the electron that is being shared will be more pulled towards the more electronegative element. All ionic bonds are polar, so it just means that the electron is fully transferred to the more electronegative atom from the less electronegative atom. So I'm just going to repeat it one more time. Covalent and ionic represent bond type, which just means are the electrons shared or transferred, and polar or nonpolar talks about how they are shared. When the bond is nonpolar, the electrons are shared equally, and when the bond is polar, the electron is not shared equally. When it is an ionic polar bond, which is the only kind of ionic bond there is, the electron is transferred. So here's a little chart to reflect that. The bond type and bond polarity are not reflected in Lewis structures because Lewis structures, they are mainly meant to show the number of bonds. You can't really tell the partially negative or partially positive charge or anything like that based on the Lewis structure. They're just meant to show that there are bonds forming between atoms in order to make a compound. But bond type and bond polarity go into depth about each bond in that Lewis structure. and what kind of bond it is and its polarity. So now we're going to talk about distribution of charge, basically how you represent where the electron is going for each kind of bond. So since electrons are shared in a nonpolar covalent bond, there's no distribution of charge. The electrons are just equally shared. In an ionic bond, the electrons are transferred. And remember, an ionic bond is always polar. So the more electronegative atom is labeled with a negative charge on the top. So it'll just be like a minus sign with a circle around it. And the less electronegative atom is labeled with a positive charge because the electron fully goes to the more electronegative atom. Now, in a polar covalent bond, we discussed how the electrons are shared unequally. So an arrow is drawn towards the more electronegative element because that is where that electron is going. Since electrons are pulled towards it, and this is what the arrow looks like. And the more electronegative atom is therefore labeled with a partially negative charge with this symbol over here and a negative, and the less electronegative atom is labeled with a partially positive charge. Okay, so we're now going to practice with bond type and bond polarity, and I gave you a bunch of information, but now I'm going to show you how to draw all those facts out in your Lewis structures and make sure that it is clear that you know which bond you're talking about. So I copied the electronegativity value chart over here so we don't have to keep flipping up. Our first example is potassium chloride. So with each kind of bond, you're going to always want to start by drawing the Lewis structure. So I have potassium and chlorine. Potassium has 1 valence electron and chlorine has 7. So we can't fully draw the Lewis structure with the bonds until we know what kind of bond we are talking about, because there are correct ways to draw each kind of bond. So let's subtract the electronegativity values. So we have 0.8 and 3.0. So we are going to subtract 3.0 minus 0.8, and we get 2.2. So if we look at our table up here, when the electronegativity is 1.8 or greater, it is ionic, and when it is 0.5 or greater, it is polar. So this is an ionic polar bond. So now that changes how we finish this Lewis structure. So we know that in an ionic polar bond, the electrons are transferred. So I'm going to draw with an arrow the electron from potassium going to chlorine. And now I'm going to redraw this with chlorine having 8 electrons and a negative charge, and potassium having none and having a positive charge. So that is how you would draw an ionic bond or an ionic polar bond, same thing. Next, we are going to draw O2. So I have 2 oxygens and I'm going to draw their valence electrons. And now let's calculate electronegativity change. So the change in electronegativity, oxygen is 3.5 and we have 2 oxygens. So 3.5 minus 3.5 equals 0. So let's look at our chart again. If the change in electronegativity is between 0 and 1.7, it is covalent. And if it's between 0 and 0.4, it is nonpolar. So we know that this bond is going to be covalent and nonpolar. So with covalent nonpolar bonds, we know that electrons are shared, but not only that, they are equally shared. So we can draw this how we would normally draw a Lewis structure, draw a circle between these 2 oxygens, but that is not enough because each oxygen there therefore only has 7 electrons. So we need to draw a double bond. And then I'm going to redraw this, the oxygens being double bonded to each other and having 2 lone pairs. So this is the final Lewis structure for the covalent nonpolar bond. Okay, so for our last example, we have hydrobromic acid. I am going to draw the Lewis structure. Hydrogen has 1 valence electron, bromine has 7. Now let's calculate the change in electronegativity. If you look on your chart, hydrogen is 2.1 and bromine is 2.8. So 2.8 minus 2.1 equals 0.7. I should have mentioned this in the beginning, but when you're subtracting electronegativity, you want to always subtract the larger electronegativity value minus the smaller one, because you can't have a negative electronegativity value. So this is 0.7. Let's look at our chart. So we know that the electronegativity value is between 0 and 1.7, but it's greater than 0.5. This is going to give us a covalent polar bond. So let me show you how you would draw that. So we know that the electrons are shared in a covalent bond. That's true. However, they are unequally shared. So this shows that they are shared. Now I'm going to redraw this. We have a bond between the two atoms. Bromine has 3 lone pairs, hydrogen has none. And we know that bromine is more electronegative, so the arrow is going to be going this way. And bromine is going to have a partially negative charge, and hydrogen will have a partially positive charge. Bromine partially gained the electron from hydrogen, and hydrogen partially lost its own electron. So that is the practice with these 3 kinds of bonds, and that concludes our discussion on bonding and polarity. So I hope you enjoyed this video on bonding and polarity. Next week, I'm going to be talking about Vesper diagrams. I will mention this again in that video, but I'm going to be only going over some of the diagrams that are at the honors chem level. So just like with periodic trends, if you are in AP Chem, you'll need to know more of the diagrams, which I'll talk about in a later video. If you have any questions, feel free to leave them in the comments. And again, I hope you enjoyed. Good luck with learning the rest of your chemistry.